Hi, my name is Stephen. This is my cloud app development assignment demo. So I built a serverless movie cast API using AWS CDK for infrastructure as code. So the backend uses Lambda functions for compute, DynamoDB for data storage, and API gateway for the REST API. So the front end is a React application deployed on S3 and is distributed globally through CloudFront. So the application also implements Lambda layers for code reuse and Amazon Translate for multi-language support. So I'll walk you through these features and show you how they work in my application. So this is my live application that's running on CloudFront. So the front end provides an interactive interface to show you all the API endpoints. So we get started by showing you the get endpoints. So this is the get endpoint for the movie roles for movie 1, 2, 3, 4. So I'll just click that and show you the output. So here we are. So this sends a get request to the movies 1, 2, 3, 4 role endpoint. So the Lambda function queries the DynamoDB and retrieves all the roles associated with that movie. So you can see we get back all the actors, the movies along with the role name, role description. So the data is being retrieved from the single DynamoDB table that's using the partition key query. So I'll show you the same for the get actor 4321. And you can see the response includes the actor's name, their full biography. So this demonstrates, another access pattern in the single table design. So it retrieves the actor's information using the actor ID as the partition key. So next I'll show you the same get endpoint, but translation to French. Let's click that. And here is the same output, but the biography is translated to French. And this API also supports other languages such as Spanish, German, and Italian. So yeah, and it also has error handling, so that if the translation fails for some reason, it'll fall back to English. So yeah, I'll show you the dynamically added inputs. So I'll show you the get movie roles by ID. So I'll just do 4321 and get the movie role. Oh, and sorry, wrong one. It should be 1, 2, 3, 4. And there's the output again. So I can search for movie roles by ID. I'll do the same for the actor. So 4321, get actor, and there's the actor and their name, date of birth, biography, so on. So I also can post add movie role. So I need the API key for this, which I have. So I'll just do movie ID. So 1, 2, 3, 4, actor ID 9999. I'll say test character, and this is a test role. Right, so I'll click add role. So yeah, there the output saying that it's successfully added to the database. So this is a 201 status code. So the Lambda function validated the input, wrote it to DynamoDB, and then returned the created resource. So this demonstrates both the post functionality but also the API key authorization, and that is working. Sort of the requirement here. So next I'll show you the Lambda layers. So there is 3 Lambda layers that power the API, with these ones being right here. So I'll show you the get movie role function. So this is used for retrieving movie roles, get actor biofn for retrieving the actor information, with optional translation, and add movie role fn, which we're in now, for adding new roles to the database. So I'll show you this specific Lambda. Let's scroll on to the Lambda section. Here are the layers here. So here you can see the shared layer that's attached to this specific function. So this is the Lambda layer that I implemented to get the outstanding tier for the rubric. So the Lambda layers allow you to share code and dependencies across multiple Lambda functions without any duplications. Each of the functions deployment packages. So my shared layer contains 3 reusable utilities. with the first being that there's a database client utility that creates a configured database document client, which are with custom marshalling options for handling empty values consistently across all of the different functions. The second is there's a transaction client or translation client, sorry, that wraps the Amazon Translate SDK, providing both error handling and automatic fallback. So, if the translation fails, like I said, it'll fall back to English. And the third is that there's course configuration module that I added with all the course headers. So it ensures that there's consistency for the cross-origin access policies across all of the three different endpoints. So all of these three Lambda functions use the same layer, which reduces deployment package sizes, improves maintainability, follows the dry principle. So yeah. So next I'll talk about the DynamoDB. So you can see my movie cast data table. So it's a single table design. So this is best practice. Instead of creating separate tables for movies, actors, and roles, everything's stored in one table, which is here. I'll just explore table items. So here's all the seeded data. So I have for movies, actor, role. For the movies, start with M hashtag, and the actors are A hashtag, and they're combined as well, to make more efficient, not to overload the database with queries. So yeah, that's the DynamoDB. This is more an efficient design because I can query all roles for a specific movie instead of just using the partition key. Or I can also just retrieve a specific actor role in a specific movie using the exact key match. So this is all without requiring secondary indexes or table scans or anything like that. So yeah, I'll talk about the API gateway now. So here's my MovieCast API. So the API is exposed to the clients. So I'm using Amazon API Gateway to create a REST API that routes the HTTP requests to the appropriate Lambda functions. So I'll just show you the resource tree here, which you can see. So this is the API structure. There's actors, there's movies and post as well for the roles. So I'll just show you that the post has a requirement for an API key, which you can see here, which is what you could see in the front end demonstration. So the API gateway also handles cores, which I previously mentioned, which is enabled to allow the React front end hosted on a different domain to make requests to the API. So this is essential for the front end to actually run correctly. I think that's everything. Just to summarize everything I've just talked about, the front end is a React application with Vite. It's deployed on S3 and is distributed through the CloudFront for fast access. The backend consists of three Lambda functions, all sharing code through a Lambda layer. So make sure that there's no code duplications. It also improves maintainability. The data is stored in DynamoDB following a single table design, making it more efficient. The API gateway also provides the REST API interface with path parameters, query parameters, and also the API key authentication, which I just showed you. Amazon Translate also enables the multi-language support for internationalization. All of this infrastructure is defined and deployed on the code using the AWS CDK, which was coded using TypeScript. So the application is fully deployed and functional. That's everything, I think. Thank you.